Today we're going to continue of what we learned last time. So we're going to discuss more about the one sample test. So I'm not going to discuss in detail because you have done this already in your Z test. And then we're going to talk about the two sample test. So the two sample test is something new to you. So the one sample test is very similar to the Z test that you did before. So after this lecture, you will be able to differentiate the type of the statistical test they use to test the difference for one sample or two samples. Okay, so there are many different types of statistical tests that allow you to test the hypothesis, which involve one sample or two samples. After you know how to differentiate between them, then you should be able to select the correct statistical test for one sample test or two sample test. Okay, you have to pick up the one that is suitable for your data set and that is suitable for your statistical hypothesis and your research questions. And you should be able to perform the statistical test for the hypothesis. Okay? So you have to be able to do it manually first. After that, we're going to learn how to do it by software. So these are the learning objectives, learning outcomes. So for today's topic, just to introduce you to more about the hypothesis testing. So far you need to learn the one sample test hypothesis. And we discussed very little about the one sample test. And then we will spend most of the time to discuss two sample tests. So there are two types of the two sample tests. One is for independent sample. Another one is for the pair sample. So first, an overview on the hypothesis testing. So far we have covered the statistical concept. So now you should know about the importance of the statistic in the research methodology, in scientific method. And also you know about the normal distribution and also sample distribution and the basic of the hypothesis testing. Okay, so far what you have learned so far is just the Z test. So we're going to learn more today. So today you're going to learn to compare samples. So you want to know if there are any significant differences between samples. So today we're going to discuss when you have one sample, you want to compare the sample mean to the population mean. Or if you have two samples that you've taken from two different populations, each of this is from each of the different populations, you want to test is if both samples are different. Those involved in the two samples is t-test and also Wilkinson test and also Mann-Whitney test. We're going to discuss more in detail later. In this course, you're not going to learn everything, just these are the basic ones. So you already have formulated a research question about the differences, or you want to investigate the differences between different treatments or groups and also the relationship. We're going to focus on this for the next few lectures. So regardless which type of the analysis they use, you follow the similar procedure. Okay, similar procedure. So these are the procedure that we use when we do the Z test. If you still remember, we formulate the hypothesis, the null hypothesis and alternative, and then we set a criteria. So we just set the criteria P equal to 0.05, alpha equal to 0.05, for example. Then you run the statistical test. After you run the statistical test, you get the Z score. Okay. Once you get the Z score, you need to find the P value of the Z score from the distribution table. Okay. Then after that, you compare the critical P value, which is from this one, okay, the one that you set alpha, with the calculated P value. Okay. Then you make a decision whether you reject or not to reject the null hypothesis. Okay. So this is, you only use this when you deal with the Z test. Okay. So when you do other statistical tests, for example, t-test, ANOVA, because for the different statistical tests that depend on a different distribution model, the table that you refer is slightly different. Okay, so for example, for z-test, you only have one table because you only have one standard normal curve, only one. Okay, but for other statistical tests, you have more than one standard curve. Okay, it's not a standard normal curve, but other distribution curve. Okay, so that's the reason why for other tests, you will do something slightly different. So the first thing is still the same, okay, to formulate a research hypothesis. Then the second one, you set the criteria alpha, okay, 0.05, and also the tail, one tail, two tail, same. And for the z-test, you stop here, correct? Okay. But for the other tests, for example, when they use a test that involves the t distribution, f distribution, and chi distribution. So the t distribution is for the t-test, the f distribution is for the ANOVA and other analysis, chi distribution is for the chi-square analysis. So if you refer to this distribution table, okay, you will need to find the critical value. If you're working on t-test, you have to find the t critical value. Okay. For the f, you have to find the f critical. Okay. So this is the t value. What is the t value when alpha is 0.05? Okay. You're going to find the t value from the table. Okay. Later we're going to discuss a little bit more. But before this, I just want to let you know so you will not be surprised. After that, you're going to conduct a statistical test. Okay, this is still the same, exactly the same. Okay, so it just depends on the test that you're going to use. Okay, so for z-test, you just calculate the z-test and you get the p value for the test score, correct? If your z is 1.5, then you just refer to the statistical table and look for the p value. Okay, but for the other test, you're not going to look for the p value. Okay. You just get the test score. You just stop here. There's no number 4. Okay? You don't have to obtain the p value for your test score, but you have the test score for your t-test, ANOVA, or chi-square. Okay? So you have the calculated t, calculated chi, calculated t, or calculated f. Okay. For the t-test or other tests that involve the t distribution, f, or chi distribution, when you refer to the table manually, you compare the critical value, not the p-value, your critical value with your test score. Okay, so if your test score is larger than the critical value that you set, then you reject the null hypothesis. So these are the main difference. Okay, when you do it manually, okay, if you use a software, okay, we still follow this one because the software will calculate the exact p-value for you. Just a revision and a little bit add-on of what you have learned. So for one sample test, you have learned how to test this hypothesis. Okay, one sample hypothesis. If you want to test if your sample mean is equal to the population mean, okay, or larger or smaller than population mean. Okay, so these are the different hypotheses for one sample. For two sample, you also have similar kind of hypothesis. Okay, so only difference is now you have two samples, and you want to each of these samples is to represent the population. So you want to compare if the population are different, or one population mean is larger than the other one. So the alternative is opposite. So it's larger or equal to the other one. So another one is smaller or equal to. Then you have the alternative. Okay. So these are for the independent t-test. Okay, so that means that you have taken two samples from two different populations. So later we're going to discuss the difference between independent t-test and also pair t-test later, after you know a little bit about the independent t-test. The next one is when you have multiple samples, more than one sample. So it's very similar to the t-test. The only difference is now instead of having two, you have more than two. So for this, usually we only test if there is any significant difference or no difference between samples. If you want to know which one is different from which one is larger than which, then we need to perform post hoc test after the ANOVA test. Okay, So you need to perform additional statistical tests after you have tested the differences between more than different groups, more than 2 groups. So for today, we're going to focus on only this. Okay. So just to show you a formula. So what this is a formula for one sample test, one sample t-test. Okay. So the only difference is this one. Okay. And also the probability distribution that we refer to. Okay. So for the rest, it's still the same, the calculation. So for this one z-test, usually we use the z-test if you know the population mean, okay, the population parameter, they tell you, and you have more than or equal to 30. You have a large sample size. If a smaller sample size, or if you don't know the population mean, you will use the one sample t-test. From the calculation point of view, it's very similar. Okay, so the only difference is during the step number 2 and number 4 when you refer to the table, statistical table. For this one, you refer to the Z table, and for this one, you refer to the T table. Okay. Then for 2 sample tests, so these are the formula. So this is for independent sample. This is for the pair sample. Okay. We're going to discuss more in detail later.